Good morning. Today we are reviewing our unit, unit number 7, having to do with the angles and all of that good stuff. Tomorrow will be our practice test, real test on Wednesday. So we started off with CO51 using the protractor. So I have my bin of protractors at the back. We'll use that on the practice test tomorrow, making sure we remember how to use it. So most of us don't have a protractor here at school. We'll use my class supply for this objective. So remember, using that protractor, you want to put the vertex of your angle right in that middle. And on the protractors, there is a line, and you match that up with the line of your angle. So you match them up the best that you can. You have your vertex right in the middle, and then you follow that top line of the angle to see where it goes. Now, to know if we're doing the inside numbers, that means that this line on the bottom is pointing to this 0. So that way we know it's the inside, so we follow our numbers going up and see where it connects. If our line matches up going this way with our angle, that's when you go to the outside, because this line would point to the 0 on the outside. Then we use those outside numbers. So always be looking, am I using the right numbers of the protractor? Remember, a quick way to check is if it is a small angle, it's acute, your measurement should be less than 90 degrees. If it is that obtuse looking angle, your measurement should be over 90 degrees. So that's your quick way to double check, did I use the right set of numbers? If it's an acute angle and you got 120 degrees for it, you know you used the wrong set of numbers. Go back and use the other set. Okay, so acute angles, they're little, they look less than 90 degrees. Double check to make sure that what you're writing down is less than 90 degrees. Remember that vertex of the angle is right where the two sides of the angles meet. Remember, acute angles are less than 90 degrees. You might want to write those definitions on your help sheet. You might know it right now, but when it comes time for the test, sometimes we forget, so it's nice just to have it written down. So the vertex is where the lines meet. I'm just writing it short and simple. Acute angles are less than 90 degrees. Right angle is 90 degrees exactly. Obtuse angles are more than 90 degrees. So write your vocab words down so you remember when it comes to the test. And then that straight angle is exactly 180 degrees. So your acute is less than 90, right angle is 90, obtuse is more than 90, and the straight angle is exactly 180 degrees. So you need to know your different angle measurements. You need to know how to use that protractor to measure your angles. Again, they will have you drawing an angle on the test. Remember, to draw a certain angle measurement, you make the vertex, you make that bottom line, then you put the protractor on top of it, lining it up. You find where that degree is. If it's like 80 degrees, it might be up here, and then you use that protractor as a ruler to connect it, and then you would put that degree measurement in the right spot. We don't want to put it on this side. If it's acute, it would be on this side, so make sure you label it so we know that your measurement is correct. Any questions on the protractors? That was just a real quick review of it, because it was a while ago that we used those protractors. All right, CO 52. I can identify complementary and supplementary angles. So complementary angles for the two angles, sum or their total is 90 degrees. And supplementary are the two angles, sum or total is 180 degrees. So you're going to want to write that so you don't accidentally flip it. A lot of times on the test, I will have students accidentally do 180 degrees for complementary and 90 degrees for supplementary. Make sure you write it out. Complementary is the 90 degrees, supplementary is the 180 degrees. Two angles. So you just need to be able to add angles together to see if they equal 90 degrees or 180 degrees, to know if they are complementary or supplementary or neither. That one was a little bit more basic, adding angles together. Or it might say, here's one angle measurement. Let's say you get 35 degrees. What would be its complementary angle? How would we find that? If a test question says, complementary angles 35 degrees, what is the other angle? How could we find that? Anybody have an idea? Yeah, Adeline. Yeah, what would we subtract that 35 degrees from?
90.
From 90, because we know complementary is 90 degrees. So if it's saying, here's one complementary angle, what's the other one? You subtract it from 90 degrees to be able to give that. Same thing for supplementary. One supplementary angle is 110 degrees. What is the other angle? Subtract that from 180 degrees. Any questions on the complementary or supplementary angles? Okay, now our next one is the vertical and corresponding angles. These ones get a little tricky. You will have to be able to say which examples are vertical and which examples are corresponding. So we need to know what that means. You cannot write examples on your help sheet, but you need to be able to know what it means. So you can write the words out on the help sheet, but you can't draw a picture of vertical angles. But the vertical angles are opposite angles that share a vertex and are congruent. What does congruent mean? Who remembers? Kylie.
The same thing.
The same measurement. So if they are congruent, they have the same measurement. So vertical angles share a vertex. So I'm going to draw the picture on the board. You cannot draw the picture on your help sheet. But I'm going to draw the picture. What we already have here is an example of vertical angles. It makes an X. So we can't draw it, but can we write the words? Yeah, you could say makes an X. So I'm not giving an example, but I'm using words to describe it. It makes the letter X when we're talking about vertical angles. Any questions on the vertical angles? Remember, opposite, they share a vertex, they are opposite, they are the same measurement. Opposites are the same measurement. This line tells me that these two angles are supplementary because there's that straight line. It's 180 degrees. So remember, we can find that missing angle using the rules of being supplementary. Our next vocab word on this objective is that corresponding angles. So corresponding angles with parallel lines. Remember, we know they are parallel because they've got those arrows there. They are going the same direction. They will never cross each other. So they are parallel. So these are angles in the same location. I'm not sure why we're doing that, gentlemen. It needs to stop. Angles in the same location. At a different vertex. On a parallel line are congruent. So remember, what this means is you pick up one line and can place directly on the second line, and angles match up. So if we are looking to see if they are corresponding angles, I would take this line and I would match it up directly onto this line and see what each angle measures. So this angle right here would plop right down on that 110-degree angle. So I know that that angle is 110 degrees. Then I can use my rules for the vertex angles and the supplementary angles to fill in all the other angle measurements. But knowing that it is corresponding angles means I can take the top line and I can place it directly on the bottom line and they match up exactly. They are all congruent. So you will need to know the difference between vertex or vertical angles and corresponding angles. You cannot draw examples, but you need to know the vertical angles make that X shape. The corresponding angles have the two lines that match up with their angles. You can write the words out on the help sheet to help you remember which one is which. Okay. Any questions on the vertical and corresponding angles? All right. Classifying a triangle by its sides and angles. So a triangle, we know, has three sides, right? Three sides, three angles. You will want to write each of, I would label it on my help sheet, triangle by its sides and triangle by its angles. Because you will have to label your triangle correctly. So if it's a triangle that is by its sides and you just give me angle measurements, that's not telling me you know what that triangle is all about. So, again, you can't draw examples, but you can write the words. The scalene triangle has no congruent sides. So each of the sides you're going to write a different measurement for. 5, 6, and 8 for the three sides. As long as the sides are measured differently. Do I want to see different angle measurements? No. I want to see the side measurements. Isosceles triangle. Two congruent sides. So you would want to show me that it has a side that's 7 and a side that's 7 and then a side that's 10. Two of the sides have the same length. Equilateral triangle has 3 congruent sides. So you would label all 3 sides the same measurement. Each side is 8, 8, and 8. So for those top 3, if you are just doing a side triangle, you just label the sides. On the bottom, it says triangles by angles. What is the important rule we have to remember about angles in triangles? What is our magic number when we talk about angles in triangles? Lila?
180.
They all 3 together equal 180 degrees. So if you label your triangle and you use degree measurements that do not all 3 equal 180 degrees, it will be wrong. So we have to remember that a triangle equals 180 degrees. I would even put that. 180 degrees equals the triangle. You can write that to remind yourself 180 degrees is our magic number. An acute triangle has 3 acute angles. So when you label your angles, all 3 have to be less than 90 degrees, and we add them up, they all equal 180 degrees. So you could have 40 degrees, 60 degrees, and 80 degrees. That equals 180, and they're all acute. A right triangle has 1 right angle. Remember, right angles are 90 degrees. So one angle is 90 degrees, the other 2 angles, you add them together with that 90 degrees and they will equal 180 degrees. So you could have a 90-degree angle, and then you could have a 30 degree and a 60 degree, or 2 45 degrees. Okay, as long as you add all 3 measurements up to equal 180. An obtuse triangle has 1 obtuse angle, 1 angle that is bigger than 90 degrees. So you could have an angle of 110 degrees. The other 2 are going to be acute. You add them up with that 110 and it equals 180 degrees. So you need to have all 3 angle measurements equaling 180 degrees, with one of them being obtuse. An equiangular triangle has 3 congruent angles. What does that angle measurement have to be if it's equiangular? Nope. 1 angle measurement. What would one of those angles have to be to equal 180 if we add all 3 together? 60 degrees. And you can even write that. It is not an example. Because 60 plus 60 plus 60 is 180. Cannot be any other degree measurement. It has to be all 3 are 60 degrees. Otherwise it won't equal the magic 180 degrees. Any questions on these? You might have to, like it says on the bottom, classify each triangle by its angle and sides. So you're going to have to write the names. Is it a scalene acute triangle? Okay. Always read the directions because here's a tip. Every year on this test, I have friends not completely read directions and they don't label correctly. If it says what is the side name And it's only asking for a side name. Don't give me an angle name. Make sure you're answering the question correctly. So you could even put a read carefully to make sure that you answer the question correctly. Every year I have kids getting ones wrong because they did not answer it correctly. They know their stuff, but they gave me a side name instead of an angle name. So be careful on this one. Put a star next to it. Remind yourself to be careful. Kelly. All right. Next is PO 55. I can solve for an unknown angle in a triangle or a quadrilateral. So again, magic numbers. Triangle equals how many degrees? James? 180. What does a quadrilateral equal? Liam? 360 degrees. Remember, any four-sided figure is going to be two triangles put together. So 180 is the triangle, two of them is 360 degrees. So when we're finding the missing angle, if it's a triangle, you subtract what you know from the 180 degrees. If it's a quadrilateral, you subtract it from 360 degrees to find your missing angles. Remembering that we might need to know that supplementary angle rules, because remember on our homework, we needed to remember the symbol for the 90 degrees. If you see a little box, we know that's 90 degrees. Okay, so you can fill in that angle measurement. We know that when our arcs are like this, that means they are congruent. We know these marks means they are congruent, so 3 congruent means all 3 angles are congruent. If it was just an isosceles triangle, it's just the bottom 2 angles are congruent. So check to see what we know is being congruent. If they give us an outside angle, we know it's supplementary to this inside angle. So 180 minus 140 gives us that inside angle, and then we can find our missing angle. So you might have to use those supplementary angles to help us find that missing angle. Any questions on this objective? All right. CO 56, the Pythagorean theorem. Who can tell me what the Pythagorean theorem is? Helen? A squared plus B squared equals C squared. Write that down. We need to know which of our sides are legs and which side is the hypothesis. How do I know which 2 are the legs? What do you think, Aiden? Yeah. The 2 sides that form our right angle are the legs. So the legs make the right angle. Again, you can't draw a picture of a right triangle and label it, but you can write out the words. The legs make the right angle. So the hypotenuse is where? How do we find the hypotenuse? That's C. Kylie?
It was directly across.
The hypotenuse is directly across from the right angle. So when we're looking at that right angle, it's directly across from it. So it's like that right angle is pointing to the hypotenuse, to that C. Remember, when we are using that Pythagorean theorem, if this was our question mark, and we had our A and our B, we know this is the C because it's across from that right angle, we would do A squared plus B squared equals C squared. So that would be 9 plus 16, because you do 3 times 3, not 3 times 2. You multiply it by itself. 3 times 3, 4 times 4. You add those two numbers together, and we get 25 equals C squared. Is that my final answer? Is my answer 25? Why not, Lila?
You have to simplify it.
Not so, you're close.
It's unsquared.
So C is squared, so remember the opposite of squaring is finding that square root. So don't forget to find the square root of that. So we have just C left over. The square root of 25 is 5. Remember, you can use your calculators. So make sure you have your calculator to help you find that square root. Do we remember how to find the square root, or do we need a reminder real quick? Anybody want me to do a reminder? You want a reminder? So on your calculator, whoops. On the calculator, if we want to find the square root of 25, we would do the second button, and then we would do where that square root is, right above the x squared. You see the square root button? Oops, I need to turn my calculator on. So you do the second, and then that square root, and you'll see that square root symbol. That square root symbol right on the calculator, and then you put the number that you want to find the square root of. And you press equal. So remember, you do the second button, and then where x squared is, right above it, it says square root. Put in your number that you want the square root of and type equal. That help, Bennett? Okay. All right. Any other questions about the Pythagorean theorem? CO 57, regular, convex, and concave. We need to know what those mean. First, is it a polygon or not a polygon? Polygons are closed. Polygons only have straight lines, no curves, and they don't cross themselves in the middle. You will want to write down all the names of the different numbered sided polygons. You will have to be able to say, oh, it says draw a heptagon. You need to know how many sides that is. So if you don't know off the top of your head right away what a heptagon is, how many sides, put this table right on your help sheet. So you can put the table on the help sheet so you know what those sided figures are. Regular polygons. So I would put regular equals all congruent. They are identical, same lengths. Then we need to know what concave is. Remember, concave polygon has a side caved in. Convex, no cave-ins. Right, you can't write examples, but an example of a cave-in would look like that. No cave-ins would look like that. No, no sides are caved in. Thank you so much to those of you for giving me your attention, not whispering to people at your table, and not acting goofy. I could pass this test. I know how to do it. You need to listen so you can pass the test. Any questions about the polygons, about the convex and concave? All right, CO 58. How to determine if they are congruent, similar, or neither. Congruent polygons are what does congruent mean? Adeline? The same measurements. So if they are congruent polygons, they are identical. Same measurements. But then we need to know, are they similar? Are they proportionate? Did it get bigger or smaller, all the sides in the same way? Who remembers how we do this? You line up your line up corresponding sides. To be fractions. Then you divide the top by the bottom. If they are similar, if similar, each fraction divides to the same number. So if you took, here, let me scroll up just a little bit. So if we had 12 over 4, 15 over 5, and 9 over 3, I divide each one up and they all got me 3s. I know it's similar. If when I match up my sides and I get different answers, then it is neither. It's not similar, it's not congruent. So you want to line up the corresponding sides to make your fractions. Divide each fraction and make sure they get you the same answer. Any question on that? So you need to remember to match up sides and then divide them. If you didn't get a chance to finish writing out the steps, you can watch the video later to finish it up. One more objective is PO 59. We know they are similar, they are proportionate. We need to find our missing side length. So remember, our methods, you could do long A over short A equals long B over short B. Or you could do long A over long B equals long, nope, I was right. Short A, ooh, I erased too much. Short A over short B. If you have the diagonal, you multiply the diagonal, divide by the one that's on the outside, that will get you your unknown. So remember, we multiply the diagonal, divide it by that outside number, and that gets you your unknown number. So you could even put that as your reminder. You can circle the diagonal and put the multiplication symbol, divide by the other, gets you your unknown. This is another one that people multiply the wrong two numbers together and then divide and they get the wrong number, the wrong answer. So you need to remember to multiply the diagonal, divide by the outside number. Any questions on this one? Now, here's the thing, friends. Our last questions on the test are always the Math 6 review. So if we look at the very beginning of our unit, of this binder, we see on the table of contents, Math 6 review. We don't know what those questions are going to be today. They'll be on the practice test. It will tell you what those POs are that we're going to be reviewing. You're going to need binder 2 to review those ones. So it's not giving us which ones we need today, but tomorrow you're going to want to bring that binder 2 to class in case you need to, after you're done taking the practice test, you need to remind yourself. There might even be, from binder 1, might even be on POs from that. It could be POs from binder 1, POs from binder 2. So remember when I said hold on to those because we might need them to review for that Math 6 review. So tomorrow you might want to check those, review those ones. Any questions on any of this math? Okay, use the last couple minutes just to review it. Remember, we have packet number 10 that's due on April 15th. You can also work on that. James? You can use a calculator on the whole test, yes. Any other questions? Gemma, did you have a question? Okay. If you are watching this review from home, I hope you are well and I hope to see you soon. Have a wonderful day.